Sure. So today, when we do a delete volume, whether it is a boot volume or a data volume, uh, for each volume delete, we go and collect the volume stats, and that call, comes from the manager.py, where we actually orchestrate the delete, and from there it goes to the driver code, and it ends up, collecting the volume stats for each volume delete. I don't have a write-up for that, but I just wanted to, explain why, that is kind of a problem. Is because, for someone or for a user who is actually trying to do a bulk volume delete, it ends up collecting the volume stats for each call, and then, the driver implementation of collection of volume stats can include, firing performance API calls, including capacity and capacity information, which kind of goes and updates the capabilities. And this is something that we have been experiencing in some of our customers, where this kind of grows inefficient, and then they start seeing warnings on Cinderlog that their volume collection or stat collection has taken more than the expected amount of time, and they keep complaining about that. We have seen a couple of you know uh, cases on that part. So the proposal that I was kind of trying to talk to Rajat about, or sometimes that we were actually having that the discussion in Slack as well, was what if the collection of volume stats is kind of a generic call which ends up updating almost capacity and all the performance information, which is kind of a generic call, because there is also a looped call that happens every X minutes of time, or configurable minutes of time, right? Which in turn kind of duplicates what that volume stat collection based on some configuration is doing with every delete call. Now, if I fire, say, 100 volume deletes, say I have a cleanup use case, I end up, calling the volume stats for each volume delete, which ends up also colliding with the volume deletes, that volume stat call that is happening, in that looped call. So that is where we are seeing the problems, because this kind of ends up bombarding the storage with a lot of zappy and API calls, which ends up which may turn to inefficient way of doing this stat collection, right? So there were a couple of recommendations that I had. One was, what if we can uh, we what if we come up with a bulk API for delete, where the customer, if they have some kind of a use case where they would want to do delete in bulk, we can actually move to that API. We can give that capability as an API, where say 100 volume deletes happen, and then we do a volume collection or a stat collection only once after the delete orchestration is completed. Second recommendation was, instead of doing that via a separate API, if I call a delete with a flag, and I'm able to send a flag, which can be an optional flag, and not every driver has to implement it. As the driver, if I think that I don't want everything to be collected as part of delete volume, I can use that flag to just do the capacity collection, which in case delete ends up changing on the storage. So those were the couple of recommendations, and we wanted to understand what would be the uh, what should be the way to go on that, because we seriously want to implement this and make sure that we don't end up with more number of customer cases on that part.
Well, I think there might be another easier solution. Well, on the bulk idea, I don't really buy that it would really solve it, because people would have to know to use it, and
Yeah.
I don't know. It seems unlikely that a lot of people would do things that way. Um, it seems to me like you could solve this problem by putting some caching mechanism in the driver stats calls, so that if you've just collected stats in the last 5 seconds, don't do it again and just return the info from a minute ago. which would alleviate this problem, I think.
Yeah,
Uh,
so that was another approach that we were exploring, which was to say add a timestamp of last collection as a capability to the driver pool, and then use that, fetch it before the volume stat happens, and just skip the volume stat if it has happened for say some configurable amount of time before. That was one more approach that we were kind of exploring.
So
But
just want to add here. Actually, I think we have one configurable parameter which you can configure in your OpenStack, and based on that is kind of the interval actually where your pool stat update will happen. So that is already available instead of means making it logical that CAS is means creating the CAS for the stat. So that also we explore. So but customer is not ready to means use that parameter.
well, that's the option for when the scheduled collection happens, right?
Yeah, there
So
is
the problem
also
here,
one.
so the problem here is every delete call triggers another stats collection. And I think the reason it does that is to try to have up-to-date info on the pool. But it seems to me if it takes multiple seconds or whatever to do the stats collection, it seems very reasonable to me to cache it and then assume.
Right. For delete, yeah, right.
but what is, I mean, why should that approach of passing a operations parameter not, I mean, why are we trying to, I mean, not take that approach as well? Because if that optional parameter is sent where, I can say that I'm calling this for this particular operation, the volume stats can actually decide what to collect and what not to, based on, I agree that it might also be efficient for us to do some kind of a time stamping on the last collection, which we can go to. That might be another layer to it. But if say tomorrow I want to call it for create and I want to specifically collect only capacity information, or for delete I just want to collect capacity information, I can use that operations flag, uh, and driver can decide what to collect based on what operation, what it is running for.
So if I did wanted to say.
No, so I think the proposal there, if I understand you, is that in the delete path, we pass in some flag that says we're doing a stats update in the delete path. And then you think your driver can then do something that's less expensive in that case.
No,
Yeah.
I think in delete at the end uh, we are means when we are doing that stat update, uh, so we can pass one optional parameter that operation type equal to delete, something like that. Okay, so we can when it will go the further actually. So it's based on the each driver how they are going to implement that one. Either they can pass it by default. This can be none for other driver, but who want to implement the stat update, it's based on that optional parameter. I think it will not harm any other driver. We just if we are passing that parameter from our end.
So my concern with this approach is like if we only, so let's say we pass this option for delete, NetApp only collects certain level of attributes from the backend, which is less expensive. But I don't know how the scheduling mechanism is. Is it based on capacity or is it based on some capability reported by the driver? So if that something goes out of date, I mean,
So
let's say for like 50 seconds ago, I did the start call. Now I call the delete. Now I'm calling delete multiple times, but there is some field you are not updating, which is required by the scheduler.
right. So as part of delete means mainly what we are thinking, we will just update the capacity related stats. So there is other performance, other deduplication related things. So using this flag, actually we can control actually which set of the stats you want to update for our NetApp Cinder driver.
So, Rajat, answering to your question of what happens if the cache is obsolete for the other information that is being collected, on a periodic basis, or say, we don't do that kind of collection. So when we actually kind of say create a volume or a delete a volume primarily, right? Whether depending on whether it is a thick volume or a thin volume, mostly what changes from the storage point of view is the capacity. And the default, say some customer is using a filter which actually kind of orchestrates their load balancing on the storage or pools depending on some capacity filter. That will definitely work as it was, right? Second thing is there is another collection that happens, which is basically the utilization, right? So we calculate that utilization and we populate that utilization based on a lot of performance calls that we do. The utilization doesn't, I mean, after a delete, we don't expect the utilization to change much on the storage side, due to which the next provisioning should get affected. That is the opinion that we were coming from.
But if I delete 100 volumes, the utilization would surely change.
That is on the performance side you're talking about, right? The utilization means the node performance and the performance counters that we
Is
get.
it?
Not the capacity. Capacity is separate. We do capacity separately and we do utilization separately. Yeah.
Yeah.
Utilization means how much this throughput and latency and those all things. Actually, it's based on that how much data you're writing on your LUN or your system actually.
Okay, I get it. So yeah, the main concern I can say for me is we are trying to implement a generic solution for a NetApp specific problem. Like I haven't seen any other backend driver reporting this issue, because we do it for all the backend drivers. And I will also give you one interesting data point we got at the start of the PTG of why it would be a problem with NetApp. So Doug is from the Ironic team. He mentioned like NetApp, while collecting the stat, lists all the, so you can correct me if the flow is wrong. It lists all the SVMs and it goes through each of the SVM, and inside each SVM it goes to each of the flex volume, and then it updates the capability. Like it tries to fetch for each SVM and each pool. Is that correct?
Yeah, you are right, because each pool is basically a flex wall. And not only that, each volume can actually belong to a separate node. So when I have to calculate or collect utilization data, I will also need to find the aggregate for that particular flex wall, which would actually give me the affinity to the node. And that is how I will go and calculate the overall utilization of the pool. And because all 4 volumes can belong to separate aggregates and separate nodes.
Yeah, but also we are also collecting all SVM data, right? Like if I'm doing the request from backend 1 for get volume stats.
No. SVM related data we are not collecting here. We just creating the object like tunneling for the SVM, and we are collecting the data only for that pools. Pool is nothing but volume.
Girish, the question is, if I have 2 storage backends with 2 SVMs, do we collect both the SVMs?
No.
Or do we collect only one
We
SVM?
whatever the volume related to those SVM, we collect the data for all those volume for that. We are not checking for each SVM. There is a connection object where that SVM is involved actually when you're creating the connection, but data we collect only for the pool. SVM is not coming picture here at all for while you're updating the volume stats.
Okay.
But it can happen that the deletion of Cinder volumes has happened from multiple SVMs, which can trigger the volume stats on multiple SVMs. But each time we go collect for that particular storage backend pool.
Okay. So if I do a request to get volume stats for a particular backend, it will only check the volume, segregates everything for that particular SVM, not for others.
Yeah.
That was my concern. Maybe Doug could explain it.
No. If you're deleting any volume, either it's belong to for what SVM, it will do that update stat for all the volume. There is no logic to differentiate. Okay, it should do that stat update for particular things, because
Particular volume, basically.
particular volume.
Cinder volume, where the Cinder volume resided.
You mean the pool?
Yeah, because at the end of the day, we are just calling get volume stats, right? So it
This
only has some parameters that it uses it. I think pool is one of the parameters that it takes.
Yeah, I mean, for the whole backend, it makes sense. Like any pool inside that backend should be updated, which is not a concern. I was under the assumption that all SVM data is collected from each different Cinder volume service. So
No, but
yeah,
as I explained, right, it can happen that two volumes, two Cinder volumes are being deleted. They are from two different storage backends, and it may
yeah,
trigger two
yeah, but
different.
there are two different Cinder services sending
Yes.
those requests, so it's not.
Okay, got it. Yeah, from the also point of view. Yeah.
Yeah,
so just want to understand actually what is the harm actually if we are passing one additional parameter, optional parameter, I can say, which will not have any impact on any driver, but we have a kind of flag or option available for the driver to control their particular stat update. Means like I don't want to update the performance related things or some other information or like that. So what is the harm if somebody is adding this one? Means,
there is no harm, just the
mm,
implementation way. Like we are trying to implement something very generic. I mean, it
right.
won't affect at this point any other driver, but yeah, I mean, I would first reach out to like why it is only specific to NetApp. Like why, what is the place it is causing this lag? So that was my main concern. Like
Mm,
if we had any other vendor, they could tell us better, but we would at least know like what they are doing different that is causing some
No,
block.
so it may also depend on the platform, right? For instance, let's say I want to collect capacity and performance. Maybe the performance APIs or maybe the performance calls that are happening are more performance intensive in case of NetApp versus any other backend.
Yeah,
So it should be the driver who controls what to collect, is what I feel, rather than collecting everything for every call.
yeah, but we should have a like strict limitation from somewhere. Like we should have it said somewhere like this is the amount of time NetApp takes to do this, and this is a hard requirement, so we can't change it. Then we have to implement something on top of it. But if it is something that is so, if you see, there are other operations also where this stat call is called. So in that way, so if you first modify delete volume, now let's say someone is retyping multiple volumes, then also this becomes a bottleneck. Then we need to modify that to provide that, okay, this is the retype command where this is causing issue. So yeah, coming to back to Eric's suggestion where we cache this, like we just need to have a new time field where we would say like this was the time last stats were collected, and whenever the request comes, we just need to match it with the time right now and see if it was done in this way. Just don't return it, don't get new stats. That would be a universal solution from driver perspective to all the operations, inter operations. So I would,
But see, there are two problems with that approach. One is that I will need to introduce a new configuration which can control what is my cache on top of what is already there, which is basically there is already a looped configuration which tells me that I need to collect all the performance stat at this particular amount of interval, right? That is one thing. Second is we introduce another sub configuration which says, hey, if my cache has already it has already been collected within this time period, even if it is a call from any place, do not go and do caching again, right? So it kind of complicates from the configuration point of view, and this is where what Girish was mentioning is that the customer did not want to add more configurations from their point of view to control this kind of a behavior, and some people may not even understand what that means maybe, and they may just end up with this problem.
first thing would be, do we really want to make it configurable?
If we don't make it configurable and we decide on behalf of the customer what is the cache duration for it to get obsolete, then there is another configuration that they have where the stats should happen every say minute per minute, right? So it collides with that. So let's say my cache can get obsolete in 5 minutes, but I run my performance stats in the loop every 1 minute. Then which one should it honor? Should it honor 5 minutes or should it honor 1 minute?
How long does this collection take in the slow case? Like how bad does it get in the current system?
So we have seen that it takes, it
30
can take
seconds, 32
around 30
seconds.
to 35 seconds, and even
So
more, right? The problem
no,
is
yeah.
when a bulk delete is fired, all these
Mm.
calls get queued, and then every delete is actually doing the same collection uh, over and over again. With every delete operation successful. So that is where the redundancy of this collection is happening, and that is where the problem is that delete actually enforces that volume stat collection to happen right now, and we are not able to control what to collect.
Even this behavior, right? Even means making all the time this stat update is even not for NetApp driver, even other driver also, right? So if somebody is deleting the 400 volume parallelly, so why it should do that parallel means one by one? Why it's some driver has to do that stat update?
Well, it seems that on most drivers, it's a fast enough operation that it just doesn't really matter.
But then why do we need to do it in delete is also a question, right?
That is kind of behavior
Or
is
why not a different API to call when the delete happens, where I can decide
It's
what to collect instead of calling that generic? Because if I do a bulk delete, then it kind of becomes redundant.
it's done in delete so that people who are creating and deleting large amounts of volumes don't have creations fail because they think the pool is full when it's not actually full.
Yeah, so bulk delete kind of becomes a different problem altogether, right? If I'm deleting a single volume which is of say 1 TB, and I want my next capacity to get updated, and based on that my filter should work and reschedule it to, or schedule it to that free pool, that is agreeable. But when I'm doing that stat collection over and over for bulk operations is kind of not making a lot of sense.
Well, that's
Because
why the
I'm
sense. I mean, you could frame it a different way. You could have your driver just do it on a periodic loop and just return whatever's there. Would be a similar effect. I mean, not needing to change the driver API when it seems like this could be fixed by just adding caching to the NetApp driver seems like it's much simpler than any broader changes to me.
But how do we deal with the problem of two configurations which are colliding with each other? Then I mean, if I decide what is my obsolescence time frame for the cache to run this again, then I'm forcing that on the customer. Versus if I create two configurations to control, one the looping task versus the delete induced collection, or even the looping task, right? There can be collisions between those two configurations. Like, what do I honor? Do I honor the cache obsolescence, or do I honor the frequent collection that the customer has configured for?
Well, I think part of the implication of this cache idea is also that you don't want to run more than one of these at a time. So I'm trying to figure out, like someone was asking a minute ago, if it actually does need to be configurable, because if the standard polling interval for the service is, what is it, 1 minute 90 seconds? I forget what it is. Yeah.
Yeah, I got your answer. So for that caching actually means what you are thinking, the few like performance related things we are moving out from that stat update, and that will making it configurable, like user can configure that one and run that one for the 5 minute of interval kind of things. So it's conflicting actually if cache and those things.
I mean,
Anup, you want to?
why does it conflict? Like, so I'm trying to understand. So Cinder calls update volume stats. Okay, is it either it's from delete volume or is it from the polling interval every 60 seconds? So what NetApp driver needs to do, it just needs to check if it is. So we will introduce a config option. Okay, that is good, but we can set a default so that customer doesn't need to set it. So let's say we set the default to like 5 seconds. Now, either the call comes from delete volume or either the call comes from like the 60-second polling interval. We don't need to handle that on the NetApp side, the polling interval. We just need to check if it is 5 seconds. Then, so I mean, I think we are trying to enforce the behavior where if sender calls the polling interval call, then we need to forcibly return the stats, which is also not true. Because if it is refreshed already in the last 5 seconds, then it is good even for the scheduler. So, I mean, NetApp should treat both of the calls as the same thing. Either it's coming from delete, retype, or the polling interval. It should just check, like, if it is 5 seconds, then within the 5 seconds, then just return the cache thing. Otherwise, return the, like, collect it again.
Yeah, because the goal is accurate enough, which will be the case there. I mean, it's never been that there's a guarantee that it's 100% accurate at all times. So as long as the kind of, I'm assuming the waiting interval when you have simultaneous deletes happening would be much smaller than the 60-second periodic window. But even if it's like 20 seconds or something, I think what I'm saying is I kind of agree with Rajat that I don't think there really is a conflict there. Because in the worst case, at any point, you're just going to return something that is still pretty recent.
So the problem with that approach is that we will have to enforce a cache obsolete timeout. And if my volume collection takes more time than the cache obsolescence, right? Then I was just thinking, where we will get a problem there. But
Right.
yeah, that is.
Need a special handling for obsoleting cache. Like, we just have a configurable value. We have the time for the last stat update. We have the current time. So we need to make the decision based out of that.
Yeah, and in some scenarios where someone has updated the cache collection to say 30 seconds, and my cache obsolete time is 45 seconds, right? In that case, it may end up doing the opposite, right?
You mean the polling interval is less than the time configured on the backend side?
On the obsolescence of cache, yes.
I would rather think that would be a rare case.
So I would still go and check whether my I'll fire that every 30 seconds, but I will see that my cache obsolescence is at 45 seconds. So, and if it takes 30 seconds to collect as well, then the next call is not going to happen. Or basically, even if I force it to be 30 seconds, I'm not going to get that collection because my cache obsolescence is 45 seconds.
Yeah, we can surely handle that case, but I was pointing at it would be a very rare case because so I haven't seen any customer configuring this to be less than 1 minute because they already expect it to be some sort of expensive in the way that periodically it will happen. So I have never seen it go below the 1 minute mark. Also, the issue we are stating here is for the bulk deletion. So if I have like 100 volumes being deleted, I think it would complete in a span of like 5-10 seconds, because delete, I think it's a pretty fast call. So I
No,
mean,
but the problem with delete is that it actually creates a lock, right? So until unless the complete deletion has completed, I don't think that lock gets released, as far as I understand. It
is it
does
the
create a
lock on the volume ID?
I think it is a lock on the database that we acquire, and then we release it after the deletion is completed.
I think that should be only for the database part of the code where we are removing the entry from the database. It shouldn't be at the entirety of the operation where the call to backend happens and we delete it and then update the database. The lock should only affect the DB update, which should be again be very quick.
Girish, do you remember whether the lock unlock happens after the stat collection or before the stat collections? Do you remember any scenario where we are?
So I think volume delete, we first log the volume, and database, I did not remember. And then we do the stat update, and then we delete the volume, and then we that I
No,
still
first
not
we will
remember.
delete the volume and then we
Mm.
will do stat collection. My only question was whether the lock is released before the stat collection or after that.
But what the
Mhm.
main point is like where on what thing the lock is. If it is on the volume ID, it doesn't like we don't care about that, because the deletion of volumes will be with different GUIDs. So there will be no locking in between for them.
Right. And
The lock for the volume ID is because like while you are deleting it, nobody should attach it or like create snapshots out of it. That's why like no other operation should be performed on the same volume. But if you are doing 100 different volumes delete, then they should happen simultaneously.
but then I would only or basically release the lock after the stat collection, right? Because before that, if someone goes and tries to provision and stat collection is still in progress, they may again run into the same problem.
Yeah, I think we release because we release it after, means we after stat collection, I think we release it because once you delete that, after that it will go the stat update and then it will return back to the manager. So manager actually where it's unlocking that volume. So we are doing it at the end.
So this may also induce that delay to the volume delete, while it should ideally have been an async call to update the stats rather than a blocking call.
But how is it blocking? I am not able to get it. Like it is blocking on a per volume basis. And it for bulk delete case, the lock shouldn't even come into picture.
Why? I mean, it is still the same volume delete code, right? So
But
locking will still be done.
But the lock is on the volume ID, and we are deleting 10,
Uh,
100 different volumes.
No, I think so. Whole process, if you sync for volume deletion, right? From the API to the manager, we are deleting the volume. It's passing to the driver. Driver deleting that, doing the stat update. Now, stat update, if taking 10 seconds or something, then once it complete, it'll go back to the manager and then update to the API. It's deleted. So whole process, which usually take 1 second, it's total taking the kind of 10 second, like. So even customer, they are not happy about this actually, if volume deletion is taking kind of 10 second and like that.
But it's
So,
not just one request calling the stat update. It could be that all the requests calling the stat update at the same time. It's not like the first
right.
request, the other request
right,
for the
right.
backend. And
Because of that, few things, few volume actually it's showing delay. It's not one volume. Volume, when I think it's loading, making lot of get call on the on tap and it's loading it, something it's happening. So because of that, actually few volume, it's delaying actually for deletion also.
yeah, and then if we cache it, so I can see the lock is specifically on the volume ID.
Right.
So
Volume.
it shouldn't, for bug delete, it shouldn't matter, the blocking part.
Yeah, you mean to say that it will not be serialized in case of bulk
Yeah.
delete. All
Yeah.
of them will happen in parallel. So
Parallel.
that we do with. But still, when we kind of induce that stat collection load to storage, right, it kind of starts inducing the delays in some time. We've seen that the initial volumes start deleting faster, but then slowly, as and when the Zappy load increases, it kind of starts becoming slow.
But if you implement this cache, then all of this request will finish quickly. Like the first one might take time, but others will quickly return from it. Let's
Okay,
say,
we will think around that case, whatever you're talking, we will think around that also. Means that solution. That also will take, no problem. But
yeah, the main difference I will tell you, like what I see is like, so you want a parameter to just update certain fields, like the capacity related information. So firstly, I don't know how much time does that take, and if it will still account to this problem, because we are doing stat collection, it is a backend call that will go over the network. So that is the first thing I'm concerned about. Secondly, it's not updating all the fields. I don't know at what point what fields are used by scheduler. In the cache thing, at least if it is even 5 seconds into the cache, I know that all the fields were updated. So at least I have all the data that is latest. So that is why I was preferring Eric's approach. Like it is more straightforward in the way that I know what will happen. The approach where we do custom queries for custom properties, I don't know the impact of it. It will require more and more testing. So that is the differentiation I see.
Okay, so maybe we will give it a thought, and we'll come back with what approach we can take. Basically, we are kind of just trying to see that the get volume start being an expensive call should not get misused from multiple places, and how to curb that for in a generic way. But if we think that adding a operation type or some kind of a flag is going to, I mean, today it might be just a NetApp problem, but it's about time, when other drivers start complaining about it too. So we were just trying to think if in those terms it makes sense for us to create a clutch on the way the get volume stats can be called from the common code to the drivers.
Yeah, this is really the surprising part. So Cinder has been working with all of the drivers, even including NetApp. So even from NetApp also, I haven't heard this till now. That's why I was interested in like what is causing this performance delay, because
Yeah, so there can be multiple reasons why that can happen, right? So if you think about a storage which is in a degraded state, say my Zappy calls are failing or are taking more time because the storage node itself is degraded, right? There can be delays due to a network. There can be delays caused due to any other reason. So the problem here is that the way volume start is actually implemented, uh, it shouldn't be used for. I mean, there should have been a separate API to update some information based on what operation we are calling, rather than using a generic collection API which kind of goes and updates everything. I mean that handling should be on the driver side rather than on the common side, because that in my opinion, right? So that is what I was kind of.
again we are jumping to a solution. I'm just saying like, so I'm not blaming Cinder or NetApp in this. I'm just saying for like last 7-8 years I've been working on Cinder. I haven't seen, even I think Fernando used to work for the
Yeah,
NetApp
it
team.
totally depends on how much scale this is being used at, right? If
Right.
if I start using thousands of volume and start creating thousands of volume and start deleting thousands of volume, there is definitely going to be a scale implication on.
But yeah, we are just doing assumptions here. Like, do we have any data regarding like what the customer workloads used to be look like previously? Now they have switched to it. Now we can do all sort of assumptions, as you said, network delay. I mean, that could be with any backend. I mean, I'm interested in two reasons why it didn't affect NetApp before, and why it's not affecting other vendors. So that are the two data points I'm more interested in. It's not about like, where the code changes should be, but if we go to the crux of the problem, these two things are my main key things that I wanted to know more information about.
Okay, sure. When we do this analysis, we'll definitely, try to publish this to understand why that delay is causing some delay, but not all.
Yeah, and as I said, like Fernando used to work, if he's around, Fernando can tell me more, like if he saw any case like this in the NetApp before.
I'm gonna stop recording.